Hi, this is ME3260 homework 8, problem 2, and we're trying to find and interpret the mode ratio for the system showed here. And as we know, the K1, K2 for the spring constant are known, and M1, M2 are known too. And the first part we need to do is to find the free body diagram. For this, we separate the four parts as we showed here. K1, K2, and F1, F2. Then we can get F1 equals to K1 x1, F2 equals to K2 times x2 minus x1. And the second part we need to find is the EOM equation for M1 and M2. For M1 equals to minus M1 x1 double dot equals to minus F1 plus F2, as we show the positive is to is toward down and the negative is toward up. So we can get equation showed here as this two. This is EOM for M1 and the EOM for M2. M2 x2 double dot equals to minus F2. Then we can get EOM equation, plug in K2 x1 x2. And then we need to find the matrix form of this equation, as we show here with the M1, M2 as here, and the other two parts are 0. For this vector, we get x1 double dot and x2 double dot is vector x double dot, and then the other part for K1 plus K2 minus K2 here and K2 here, as we show the equation above, and then times the vector x as x1, x2 equals to 0. So then we can get mx double dot plus kx equals to 0, and then we can find the x equals to v e to the st as shown here. And what we know, what we need to find is s and v. We need to find the s first. So s squared m v e to the st plus k v e to the st, as we got up from above. We can, because e to the st are the same, we can delete these two parts. Then we can get this time v times v equals to 0. For the first, we can get v equals to 0, and this is a trivial solution. And then we need to find this part equals to 0 to get determinant k plus s squared m equals to 0, as this part is a matrix. So then we get k plus s squared m equals to k1 plus k2 plus m1 squared and k2 plus m2 squared minus k2 here. Then we just use this times this and plot minus this part times this part. So then we can get this equation here. And K1, K2, M1, M2 are known, so we can plug out the numbers here, as we got 10 s squared plus 3 times 10 to the 4th times 30 s squared plus 2 times 10 to the 4th minus 2 times 10 to the 4th square. Then we can solve for s. As I showed here, we can get this equation, and we use it to solve the problem, as we can get s squared equals to minus 3475 and minus 392. So s equals to square root of 3475j and square root of 192j. This is the mode frequency as shown here. So then we plug the s to the initial equation. As we plug s squared equals to minus 192, we can get we can plug, this is where s squared is, and this is where s squared is, as we showed the equation before for the matrix. Then we can solve the v vector here using this matrix. Then we can get v2 equals to 1.404 v1. Then we can get the matrix here. This is called the in-phase mode shape, And then we use the same way to do for the s squared equals to minus 3475. And we just plug where s squared is as here and here. Then we solve all the matrix system using this using its rule, and then we can get V2 equals to minus 0.2375 V1. V2 equals to this V1, and then we can get this. This is called out of phase mode shape. This is what we pretty much got so far, and then we need the last part we need to do is to solve for this homogeneous solution. Then we just plug in all this using the S we got. So finally we get S equals to this x1 x2 equals to 1 and 1.404. Plug in the S first part times c1 e to the square root of 192j plus c2 e to the minus e to the square root of 192j, and then we can get the same as here, 1 and minus 0.2375 times c3 e to the square root of 3475j and plus c4 e to the square root 34 minus 30 square root 3475j, and then we can using the Euler's identity to simplify this, and then we can get all this equation shows here. That's the answer for this problem. Thank you very much.